Today's lesson, we're going to talk about the product rule. The product rule says and allows us to find the derivative of a product of two polynomials. So let me write down our product rule for you. It's going to be helpful if you use color in your notes today, so I'm going to do my best to do the same so that it brings some things out to your attention. We've got dx, here's our rule. If I take a polynomial or some algebraic expression, some function, times another function, the rule says the derivative of the first times the second plus the derivative of the second times the first. And I'm going to use that language quite a bit. So here's where I'm going to use some color because this is really, really important. This is our product rule. The derivative of the first times the second plus the derivative of the second times the first. Here's our first and here's our second. So I'll make a little red ball so that little like a karaoke ball. There we go. So there's our first, there's our second. The derivative of the first times the second plus the derivative of the second times the first. It's that easy. Just keep saying that over and over in your head or listen to me say it and you'll be good. So here we have the derivative of y equals 3x minus 2x squared times the quantity 5 plus 4x. You might be thinking, why can't I just multiply this out? They're two binomials. I can do that pretty quickly. And yes, you can in this case, but you're going to see some other problems well, we're going to have our quotient rule, of course, as well. But you're going to see some other problems where it's not going to be as easy to do that because we're going to be talking about rational exponents, which are radicals. So it's not always as simple as radical equations. You can't really multiply a radical equation times a polynomial. So this is why the product rule is going to be important. Let me get to it here. So the derivative of y with respect to x is equal to, I'm going to find the derivative of the first. The derivative of the first is 3 minus 4x. And then I'm going to take that times the second. So that's 5 plus 4x. And then I've got plus. Now I have the derivative of the second. The derivative of the second is 4 times the first, which is 3x minus 2x squared. And now we simplify. So now I have, let's see, 3 minus 4x times 5 plus 4x. That's going to be negative 16x squared. And then I'm going to have negative 20 plus 12 is negative 8x. And then 3 times 5 is 15 plus 12x minus 8x squared. We'll combine like terms. I get negative 24x squared plus 4x plus 15. And that is what our derivative is, which we write as dy dx. Excellent. So here's one for you to try. Go ahead and try it and then press pause because I'm going to go right to the answer on this one. So press pause and then come back and check your answer. Okay, the answer on this one, dy dx, is equal to negative 27x squared plus 12x plus 24. I'm going to bubble that one. There we go. Okay, let's try another one. This time one that's not as simple to FOIL out. So here we have f of x equals 1 over x plus 1 times the quantity x minus 1. F prime of x is going to equal, again, I have the derivative of the first. The derivative of the first, 1 over x, is the same thing as x to the negative 1. So the derivative of the first is going to be negative 1 over x squared. And then that's times the second plus the derivative of the second, which is 1, times the first, which is 1 over x plus 1. And now I'm going to distribute and simplify. So negative 1 over x squared times x is negative 1 over x plus 1 over x squared plus 1 over x plus 1. So negative 1 over x and positive 1 over x cancel out, and our derivative is equal to 1 over x squared plus 1. Now, I could box that, however, simplified means writing it in one fraction. So I'm going to get a common denominator here. So I'm going to put this over x squared. So that's going to give me 1 plus x squared all over x squared. And that's going to be my answer. Let me write equals f prime of x right there. And then I'm ready to box it. There we go. Okay, let's do another. Y equals 2x times the quantity x squared plus 3x. dy dx, which some of us are already writing y prime, which is fine. The derivative of the first is 2 times the second factor, which is x squared plus 3x, plus the derivative of the second factor, which is 2x plus 3, times the first, which is 2x. And then we're going to distribute 2x squared plus 6x plus 4x squared plus 6x. So our derivative is equal to, it looks like 6x squared plus 12x. Now, it says, this is versus. So now let's look at this one. And I'm going to do the product rule here because it's important for us to be able to do the product rule. So we know that this is the constant multiple rule right now. We can just take 2 times 3x squared plus 6x and be done with it. But if we wanted to use the product rule here, the derivative of the first is 0 times x cubed plus 3x squared, plus the derivative of the second is, the second one is 3x squared plus 6x times the first, which is 2. This 0 cancels out, right? It's just 0. It doesn't cancel out, it's just 0. And then 2 times 3x squared and 2 times 6x, that's 6x squared plus 12x. So we're adding lots of tools to our toolkit. Some roads, some tools that we use are going to take us a little bit longer to get the answer, and other tools are going to take us down a more efficient road. That's why it's very, very important for us to know all of our tools, so, and know what they're called. So for instance, this one on the right, this beautiful one here on the right, that one is that constant multiple rule, which we've talked about. And it's important for you to know that constant multiple rule because it will make your life easier, because we don't always do the product rule. Now the product rule extended, we can extend this. It doesn't just have to be 2 factors. We can take 3 factors. So the derivative, when I have f of x times g of x times h of x, is equal to the derivative of the first times both the second and the third, plus, and you can probably guess already, the derivative of the second times the first and the third, plus the derivative of the third times the first and the second. And there's no brackets there, so we're good. So that's the extended product rule, which might occur. It doesn't happen very often, but it could occur, in which case you would use this extended rule. Now I'm going to use a pretty color here because this quotient rule is, purple's always a pretty color. Our quotient rule is a good one. If I've got the derivative of f of x over g of x, so I've got a factor in the numerator, a factor in the denominator, a variable factor in the numerator, a variable factor in the denominator. This is how it goes. The derivative of the top, or the numerator, derivative, I'll usually say the top and the bottom, I think, but the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. So this is a minus, and then that's all over the denominator squared. The denominator squared. I apologize if that's a problem, that barking. Sorry. Okay, so we have the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. And obviously the denominator cannot equal 0. Let me show you how this works. Again, I'm going to use color. So I've got x minus 1 in the numerator. I've got 2x plus 3 in the denominator. Here we go. The derivative of y with respect to x is equal to the derivative of the numerator, which is 1, times the denominator, which is 2x plus 3, minus the derivative of the denominator, which is 2, times the numerator, which is x minus 1. And that is all over the denominator squared, 2x plus 3 quantity squared. Now we simplify. Sometimes it's not the calculus that causes us the problem, it's the simplifying. That's why college algebra is such an important preparation for moving on to higher levels. So we've got 2x plus 3 quantity squared, 2x minus 2x cancels out, and I get 5 over 2x plus 3 quantity squared. And that is our, I'm going to put y prime just to save me some room here. And time, I guess. 5 over 2x plus 3 quantity squared. That's the quotient rule. So go ahead and give the other one a try. Press pause. While you're working it out, I'm going to write it out. So when you're ready, come back. But you really do you owe it to yourself to try this one. So what you're doing right now, if you're back with me, is you are checking your work. And maybe you're looking to see how fast I'm doing this problem, because that's how fast you should end up being able to do this problem. So your speed should be very similar to my speed very soon. So that's the minimal amount of work that would need to be shown to find the derivative of y with respect to x in this case. Okay. So now we're going to find the equation of the tangent line to the graph of y equals 2x squared minus 4x plus 3 all over 2 minus 3x when x equals 1. So what is it that they want us to do? They want us to find the equation of the tangent line. So to find an equation, we need a point and a slope. Correct? Correct. Okay, we've got one value of the point. Here we go. One value of the point is coming from x equals 1. So I'm going to have x equals 1 comma something. How do I figure out where that point is? Well, I'm going to have to take that 1 and substitute it in and find the corresponding y value. So now what you're saying is, hopefully not, I'm confused, this makes sense. To find an equation of a line, we just go back to Algebra 1. To find an equation of a line, we need a point and a slope, okay? So a point is an ordered pair, and they only gave us one part of that ordered pair. So we need to find the corresponding y value. So we shall do that. Let's do it now. We put a 1 in for x, and I get 2 minus 4 is negative 2, plus 3 is 1, and then I get a negative 1 in the denominator, so when I put a 1 in, I get a negative 1 out. Let's not make that red because I already used red somewhere else, so let's make it blue, negative 1. So we find the corresponding y value. There's our blue. Beautiful. So now I've got my point. I'm going to highlight that in green. Excellent. I need a slope. How do we find the slope of the tangent line? How do we find the slope of the tangent line? Well, that's what we've been doing. That's what we've been doing. We've been finding the slopes of the tangent line every time we find the derivative. That's why it's so important to understand that the derivative is the slope of the tangent line. So that's what we'll do. Y prime is equal to the derivative of the numerator, 2x squared minus 4x plus 3. The derivative of the numerator is 4x minus 4 times the denominator, 2 minus 3x, minus the derivative of the denominator, which is negative 3, times the numerator, which is 2x squared minus 4x plus 3. And that's all over 2 minus 3x. So let's simplify this. We could simplify it, but what do we want in the end? Do we want an algebraic slope, or do we want a numerical slope at a given x value? So what is it that we want? We want the numerical slope. So if we want the numerical slope, what can we do? We can go right to putting x equals 1 right in here. And then we don't have to substitute in, not substitute. Then we don't have to, then we don't have to simplify it algebraically. We could just put that 1 in right there. So when I put the 1 in, I get 4 minus 4 is 0. And then 0 times anything is going to be 0. Minus negative 3 times, I put the 1 in, and I get 2 minus 4 is negative 2. Negative 2 plus 3 is negative 2 plus 3 is 1. And I just realized the denominator squared. I don't even know if I said that, but that's what I meant. So got to go back and fix that, because that's a game changer. You got to square that denominator. And then that's all over 2 minus 3 would be negative 1. Negative 1 squared is positive 1. So I've got 0 plus 3 all over 1, which is 3. So the slope of the equation of the tangent line, the slope of the tangent line is 3. The equation of the tangent line, now I'm going to use these two things. Let me highlight this in blue. So now I've got a point, I've got a slope. Y minus negative 1 is equal to 3 times x minus 1. Y plus 1 equals 3x minus 3. Y equals 3x minus 4. That is the equation of the tangent line at x equals 1. So that's what we found. So it's important for us to kind of write down in words what it was that we just did, because we are in new territory here that could start to become very complex. Okay, very, very complex. So let's write down our steps that we took. So step 1. We found the derivative, which is the slope of the graph. Okay, that was one thing that we did. Another thing that we did was we substitute x equals your number given in the problem into your derivative to get a numerical slope, to get a numerical value for your slope. Yay. So this right here accomplishes finding the slope. And then step 3, we need, what do we need? Step 3 is we need the point from the original graph. And step 1 and 2 could come after step 3, or step 3 can come after 1 and 2, but 1 and 2 go together. That's why I use little braces there. We need the point from the original graph at shared at the tangent line. I don't want to say it that way. I want to say shared by the graph and the tangent line. So the tangent line and the graph are going to have that one point where the tangent line just touches the graph and bounces off. We want that point. So it's going to be that x equals that number that's given in the problem, and then you're going to have to find the corresponding y value. Sometimes they give you the ordered pair, and sometimes they just give you the x value, and then you have to find that y value. And then boom, bada bing, bada boom, you got it. Okay, so these steps will hopefully be very helpful for you. Okay, so we've got some more quotient rule. So we're going to go through this real quickly because it's all about being able to do these derivatives rather quickly. So dy dx, the derivative of the numerator, I've got negative 1x to the negative 1. So that's going to be that's going to be positive 1 over x squared. So the derivative of the numerator, let me use some color here, is going to be positive 1 over x squared, and then times the denominator, which is x plus 5, minus the derivative of the denominator, which is 1, times the numerator, which is 3 minus 1 over x, and then that's all over x plus 5 quantity squared. So dy dx is equal to, I'm going to distribute, I'm going to get 1 over x plus 5 over x squared minus 3 plus 1 over x, all over x plus 5 quantity squared. And this is going to take some algebra here. I'm going to have 5 over x squared plus 2 over x minus 3 all over x plus 5 squared, quantity squared. I'm going to multiply each term. Let's use a different color, green maybe. I'm going to multiply each term in the numerator by x squared because I have a complex fraction, each term in the denominator by x squared, and that's going to give me negative 3x squared right there plus 2x right there plus 5 all over x squared, I'll write the monomial first, times x plus 5 quantity squared. And that's our derivative. Okay, the next one is for you to try, and I'm just going to give an answer. I'm not going to show my work, so I'm going to give my answer. So press pause and then come back when you're ready to reveal the answer. Okay, here's the big reveal. We've got y prime equals negative 3x squared plus 4x minus 8 all over, actually plus 8, negative 3x squared plus 4x plus 8 all over x squared times x plus 4 quantity squared. Yay! Okay, rewriting. How would we rewrite this one on the left? Y equals x squared over 6 plus x over 2. That's how we would rewrite that. And then what's our derivative? Our derivative multiplied by 2, and we get 1/3 x plus 1/2. How about the one on the right? How could we rewrite the one on the right? Well, let's do a little simplification. We've got negative 9x plus 6x squared all over 7x. So I'm going to rewrite this y equals negative 9 over 7 plus 6x over 7. So my derivative is equal to 6/7. So easy, a caveman can do it. I don't even know if you know that commercial, but it's a good one. So for you to ponder, how many different ways can you find the derivative of this equation? How many different ways can you find the derivative of y? Think about it. Think about it, think about it, think about it, and be prepared to actually have to follow through on some of those ideas. Hope you enjoyed this lesson. You may have to rewatch it a couple of times because we went kind of fast through that algebra, but that's where we're at in calculus right now. We gotta just power through all that algebra. That's the part that's going to be the most time consuming in some cases.